Hello and welcome to this lesson on unit prefixes. My name is Mr. Van Hook. I am the Director of Science at Midhurst of the College and I'm one of the physics teachers there. In this lesson what we're going to do is look at the unit prefixes to be able to know the order of them and be able to use them in some common situations. So I would expect you at this stage to know some basic ideas about units of measurement. For instance, that length is measured in meters and so on. If you're unsure of these, then I would suggest that you go and do some pre-reading just to review some of those key ideas about units. So before we embark on this lesson, just to be sure that you're clear of that, have a go at answering these 4 questions. Hopefully they're all very straightforward. And then when you are ready, you can look at the next slide. Press pause and then take a look at the next slide in a moment. So hopefully no surprise with any of these answers. The one thing that I would draw attention to is the idea about what is measured in grams. It is mass. There will be a lot of situations where weight is often referred to, and I guess in day-to-day speak we do talk about our weight being perhaps 70 kilograms or what have you. But weight, strictly speaking, is a force and so should actually be measured in newtons. We reserve the term mass, which is the amount of a substance or the ability of a substance to resist a force, but we refer to that in grams, and even then we typically call that kilograms. We can deal with that a little bit later on. So the units and the prefixes that we are learning about here are part of something called the International System of Units, or the SI Units. This is a system that's been adopted by scientists around the world in order to keep things simple to understand and avoid confusion between scientists working in different countries and different cultures. So it's an absolutely crucial system that we're able to use to express all sorts of measurements and calculations. Prefixes then are used as a shorthand for standard form, and we use them particularly when we're using very large or very small numbers in science. So we've got a couple of examples here. An example from biology, the size of a virus may be about 0.0000000023 meters. Well, if we're writing that or talking about that number with people, it's very easy to lose track of the number of zeros that we have said. So we can use standard form, and we've got here 2.3 times 10 to the minus 9 meters. For those of you who perhaps aren't familiar with standard form, there is another lesson in this series on standard form, so do look out for that. But to make things even simpler, what we can do is, instead of talking about times 10 to the minus 9, we can just say 2.3 nanometers. And what we should be familiar with is that when we see a small n in front of an m, the small n means times 10 to the minus 9. And it's getting familiar with what each of those prefixes mean that's the key thing we need to do this lesson. Here's another example, a more physics example here. The typical peak UK electrical power demand is around 33.5 billion watts. And we can express that as 33.5 times 10 to the power of 9, or much simpler, we can talk about that as 33.5 gigawatts. And the key bit of knowledge that we need to have there to understand that is that 10 to the power of 9 is a giga, or giga means 10 to the power of 9. Or if you like, when you see giga, you need to think billion. So those are those key things there. So in all of these examples, what we're trying to do is we're trying to choose the most appropriate prefix so that the number we're dealing with isn't an incredibly large number or an incredibly small number, but a number that is easier to make comparisons with without losing track of the number of zeros. So this table here shows us the key prefixes that we need to know about at A level, and I have covered here the full range that's needed for A level physics, although for A level chemistry and for biology the requirements are slightly different. So what we can see here is that there is a clear pattern in how these prefixes are arranged. What we have is we've got a different prefix for each, I guess, a step of 1,000. So if we start here in the middle here, we multiply just 1 by 1,000, we call it a kilo. So for instance, 1 meter, if you have 1,000 meters, we know we have a kilometer, okay, kilometer, km. And so what we're doing there is we're multiplying by 10 to the power of 3. If we have got, let's say, 1,000,000 watts of power, we can talk about that as a megawatt. And we've gone up a step there of 1,000. We've gone up an order of magnitude of 1,000 to 10 to the power of 6. And so we can see here the pattern going up. We go 10 to the power of 3, 10 to the power of 6, 10 to the power of 9, 10 to the power of 12, 12 being tera. So we could, for instance, in computer science, we often talk about terabytes, and that's 1,000 billion bytes of data. And then at the other end of the scale, things that are incredibly small, we might have, for instance, picoseconds, which is an incredibly short amount of time. Now, a handy way that we can remember this, because we do need to know the order and be able to recall this really easily, is using this mnemonic. The great Michelangelo knew many unseen new painters. And what we've got here, we have to particularly look at the capitalization. It is a sentence, so we capitalize T. Great Michelangelo. We're going to name Michelangelo great, so we'll call him Great Michelangelo. But after that, everything else is lowercase. I guess the one key sort of exception perhaps to this is we've got this symbol here for micro, and we've got a U here. This is a Greek letter, the Greek letter mu. That's how we say it, mu, but it looks like a U with I guess a tail at the front. For completeness, I have also put the other two units that we would be familiar with, and particularly so if you are doing chemistry. We've got down here at the bottom the deci and the centi. You should also be aware of how we use those. So this is the key table, the key knowledge that we need to have, and then what I'm going to do is show you how to apply it in the next couple of slides. So here we've got 3 examples where we are going to try and write the number out in full given these abbreviations. So I'll do the first one, I'll do the first couple, and then what you can do is have a go at doing the third one yourself, and then I'll show my worked example. So here we've got 65 kilometers. What we need to do is we need to recognize that the K means times 10 to the power of 3. That's what we can see on that table. So we're going to write here 65 times 10 to the power of 3, and I'm going to write this out as a number in full, and so what we've got here is 65,000, and we must remember that we haven't got rid of that m, so we keep that and we call it 65,000 meters. Let's take a look at the next one. Here we've got 112 millimeters. The milli refers to 10 to the minus 3, or you could also rephrase that as multiplied by 0.001. I'll use that second approach for this one here. So what we do here is we're going to write 112 multiplied by 0.001, and that gives us an answer of 0.112, and again we must use the meters because we haven't got rid of that, so that's our answer there. Right, let's have a look at this last one here, 0.36 gigawatts, gigawatts of power. I'll remind you here that giga means 10 to the power of 9. Why don't you take a moment to see if you can work that out and write it out as a full normal number. So hopefully what you have done here is you will have done 0.36 multiplied by 10 to the power of 9, and you will have got an answer here of 360,000 watts, 360 million watts. We can also refer to giga as times 10 to a billion. And so in that case we would do absolutely the same of 0.36 times 10 times a billion, and we get the same answer that we had previously. Okay, so here's a different way of using these, and I shall explain how we can do these. If we want to go from a sort of normal number and turn it into a number with a prefix, a unit with a prefix, rather than taking the number and multiply it by whatever the prefix represents, what we do in these cases is we take the number and we divide it by whatever the prefix represents. So to get rid of a prefix, we multiply. To introduce a prefix, we divide. Let me show you that with a couple of these, and you can have a go with that third one here. So here we've got our 45,000 meters. The key thing here is it already looks like we need to do 1,000, and with 1,000 we remember that we can do kilometers or kilo. So what I'm going to do here is I'm going to divide this by the 1,000, or you could say you're dividing it by 10 to the power of 3. 10 to the power of 3, or 1,000, is the kilo, and so we get here an answer of 45, and that's where we now put in the kilometers. So to introduce a prefix, we divide by whatever that prefix represents. Let's have another look at this next one here, 0.007 amps. What we can do here is we can divide by 0.001. So we divide by the number, the order of magnitude that seems closest to the number that we're dealing with here. So I can here do 0.007, divide that by 0.001, and what I get is I get an answer of 7. The 0.001 referred to milli, and so I can have here milliamps. To look at it ever so slightly differently, I've got here 0.007. I can divide that by 10 to the minus 3, and again I get 7 milliamps. Remembering that 10 to the minus 3 refers to milli. So when we're introducing prefixes, we divide by the number that seems to represent it. So let's have a look at this last one here. This is something that's around about a million. So have a think about what is the most appropriate prefix for a million. And then we're going to introduce the prefix, so you need to divide by that to get your answer. Don't forget to actually write in the prefix as part of your answer. Take a moment to do that, and then I'll show you the answer. So hopefully what you've realized here, this is around about a million. So we're going to do 5,400,000. I'm going to divide that by a million. And so that's going to be 5.4. And we remember that a million is represented by a capital M for mega. And so we've got 4.5 megajoules. So in some situations, what we need to do is go from one prefix to another prefix. Perhaps that's because we need to do some comparison of quantities, or we need to do some other calculation. which is referring perhaps, in this first example, it's not referring to megawatts, but kilowatts perhaps. Perhaps we're trying to calculate the cost of electricity or something like that. So what we need to do here is we need to take our original number, here in this particular case our 34 megawatts, and we need to turn it into just a standard number, turn it into just standard watts, and then do a second step where we put it into kilowatts. So let's do this first one here. Here we have got we've got 34, and we're going to multiply it by megawatts. Now hopefully you can remember the number, or that standard form, the exponential, that mega represents, and it is a million. So we do 34 times a million to get 34 million watts. What we now need to do is take that 34 million watts and put it into kilowatts. So we're now going to introduce a new prefix. And we remember that when we introduce a new prefix, we'll be doing multiplication or division. We need to do division. We divide by what the kilo represents. So here I'm going to now do 34 million. I'm going to divide that by 1,000, and that gives me an answer of 34,000, and this here will then be kilowatts. So now we've got another example here, 750 milligrams expressed as a kilogram. So what we need to do here, we're going to turn our milligrams into kilograms. We remember that milli means 10 to the minus 3. So we do 750, I could say 10 to the minus 3 or 0.001. 750 times, I'll do 0.001, and that equals 0.75 grams. Always important to make sure you put a unit at the end so you can remember what actually is the suffix, if anything, that belongs to that number. Okay, so now we've got that, we now need to turn that grams value into kilograms. So kilograms, we know, is 10 to the power of 3. And we remember that in this particular case, to introduce a unit, as we're about to do here, we divide by what that represents. So here we're going to do 0.75, I'm going to actually add that trailing 0, 0.750, divide that by 10 to the power of 3, which is also 1,000, I'll write that there as 1,000, and that is then going to equal 0.00075 kilograms. Now hopefully you can see that at this point that 0.00075 kilograms, it's beginning to get a little clumsy, we're beginning to get lots of extra zeros in. So either the 750 milligrams would be fine, or the 0.75 grams. But the kilogram is a special unit, because in the SI system of units, the kilogram is the standard unit for mass, whereas the standard unit for length is just a meter, not a kilometer. The standard unit for time is a second, not a kilosecond. And the standard unit, let's say for current, is an amp, not a kiloamp. So mass is the odd one out. Mass is the unique one. Mass, we always refer to kilograms as our sort of standard one. But what I recommend you are doing here is you are turning things into grams, and then you do that extra step of dividing by 1,000 to go into kilograms. On the next 3 slides are a series of example problems that you can now have a go at, and on the very final slide are the answers to those. I hope this lesson has been useful to you. Thank you.